Okay, this lesson is on prime factorization. And remember I had you guys download my website on to your iPads? On my website, the biggest thing on my website that you're going to use are the vocabulary cards. I made Quizlet vocabulary cards for each chapter. Okay? Because in 7th grade, vocabulary matters. You guys came to me and you knew the toothbrush method, which is a great start, but you're going to need to know the correct terms, especially before you go into 8th grade free algebra. Or some of you might test out and get into algebra, which is a 9th grade class. Prime factorization, we worked on it last week as one of our bell work. Every composite number can be expressed as a product of prime numbers called the prime factorization. A factor tree can be used to find the prime factorization of a number. Now I'm going to underline factor tree. You need to underline the word factor tree because this is what you're using to factor your numbers. It's called a tree. Complete the factor tree to show 2 ways to find the prime factorization of 36. This is written a bit different than what I taught you. So I'm going to kind of show you what they mean, and then I'm going to give you my shortcut. So if we have 36, you start with 2 numbers, 2 factors that can get to 36. So 12 times what gives me 36?
3.
So we're going to write a 3. 3 is prime, correct?
Yes.
So I can't factor it out anymore. Oops. And so if I can't factor it out anymore, the 3 boxes going down means you write the 3 each time. So I'm going to have to write 3 and 3. Go ahead and do this, but I'm going to show you my shortcut. Then you had to factor out 12. So 3 times what gives me 12? 3 was prime, so they just brought it down again. But 4 is not prime, so we have to factor that again. So that's 2 times 2. But then, bless you, but then we're going to write the prime factorization. Remember, it has to go least to greatest. So we're going to write it as 2 times 2, because there's 2 2's, times 3 times 3. Then I showed you last week another way of writing it with what do they call those little numbers? With exponents. Very good. So you're going to write it 2 squared times 3 squared. With my shortcut, I said once you got to a prime number, you can circle it. So then now let's take our pencil and just do a light scribble through. 3 was prime, so I'm going to circle it, scribble through that other stuff. 2 is prime, 4 is prime, and I'm circling those. For me, these 3's get confusing. Like you're going to want to put it in too many times. We're finding a second way to find the prime factorization of 36. So 18 times what gives me 36?
2.
What?
2.
2. And because 2 is prime, I'm going to circle it, and I'm not going to fill that out. We're going to use my shortcut. Then 18 is 2 times what?
9.
Put the 9 in the box.
Circle the 2.
Circle this 2, because we're not going to worry about that one. And then what are my factors of 9? 3 and 3. And we're going to circle those as well. And then we rewrite it 2 times 2 times 3 times 3. Or 2 squared times 3 squared. Now I wrote on these lines, and you might have also, but we can still answer this question in our margin. It says, is there another way to find the prime factorization of 36? So let's write the number 36. Let's start the factor tree. What are 2 other factors that I can multiply to get to 36? 6 and 6. 6 and 6 are not prime, so I need to factor them out. What gives me 6?
3 times 2.
3 times 2 or 2 times 3. Again, you write it again. Now I am done with my factor tree and you write it the same way. And I want you to write this in your book in the column. Everybody should be writing this down. It says, if you use different factors, does a prime factorization change? So did my final answer change? No, just like I explained last week. You can start with any two numbers as long as you keep factoring in and keep going until they're all prime. Yes? The test of the hybrid car resulted in 4,840 miles driving using 88 gallons of gas. Find the prime factorization of 88. So let's say I'm going to start with 88 and I don't know where to begin. So I just start thinking, what kind of number is it? Even or odd?
Even.
If it's even, I can divide it by 2. So I'm going to divide it by 2. So it would be 2 times what? 44. 2 is prime, so I'm going to stop there. 44. Is it even or odd?
It's even.
Even. So I'm going to divide it by 2. So 2 times what gives me 44? 22. Oops. Circle the 2. 22 is still even, so it's be 2 times 11. Circle, and 11 is also prime. So there is my prime factorization. But you need to write it out. 2 times 2 times 2, and then times 11. And then you also write it with the exponents. So how would I write it with exponents? 2
To the third.
to the third power
To
times 11. Turn the page in your book, please. Be at the top of the next page. It says powers and exponents. A product of repeated factors can be expressed as a power. That is, using an exponent and a base. The base is what you multiply by so many times. Okay? The exponent is how many times you multiply this by itself. Let's look at this chart, because and this is how you read these numbers. So this would be 3 to the first power. Then we have 3 to the second power. But I want you to put a line through that a little bit, because I want you to get more used to saying it is 3 squared. When you see a little number 2, it's squared. Then I have 3 to the third power, or 3 cubed. I want you to cross off to the third power and get used to saying that it is cubed. After that, you're going to read it to the power. So this is 3 to the fourth power. And then it has these dots. So then if I would have like 3 to the fifth, you would read it 3 to the fifth power, 3 to the sixth power, 3 to the seventh power. This is why they have an n here. 3 to the nth power. Nth power, that means the n can be any number. Okay? So let's work on some examples. Now, when I tell you guys, when you're doing homework at home and I say, hit the tutor button, watch the videos, that's this button. For some reason in the Indiana pages, it does not work. Because this button should be purple. So it's not going to work in the Indiana lessons. But it will when we get out of the Indiana lessons. So it says write 4 times 4 times 4 times 4 times 4 using an exponent. So the base would be what number?
4
4. And then how many do we multiply it by?
times 5
Times 5. So it's 4 to the
fifth power.
fifth power. Second example, write 2 times 2 times 2 times 5 times 5. So that would be
2 to the third.
2 to the third
And
times 5.
to the second.
Don't say to the second. 5 squared. Squared. We got to get used to that term. So if you have to, study that chart. Notice I'm using a dot, not a multiplication sign. Okay, I want you guys to have that dot instead of the multiplication sign. We're going to come back and do these examples.
Okay.
So turn, and let's look at 2 more examples. These are prime factorization using exponents, which I've just already explained as we've been going. You can use a factor tree to find the prime factorization of any composite number. Write repeated factors using exponents, which I have been showing you. So it says find the prime factorization of 24. Write the result using exponents. So we start with 24, 3 times 8. Circle this 3. Scribble that out. That gets confusing. Then split the factors of 8, 2, and 4. 2 is prime. So circle it. And then I need to split the 4 by 2 times 2. Okay, I need you to show that work that you're going to circle the numbers that you end at. Now, it starts with a 3,
Yep.
right?
Yeah.
So many of you probably want to do this. 3 times 2 times 2 times 2. Is that correct? No, because it has to be least to greatest. And I have the same problem. Sometimes I make that same mistake, but I have to just double check. So you're going to write 2 times 2 times 2 times 3. You're going to write that out first, and then it would be 2 cubed times 3. Let's look at number 4. 120. Let's say we don't know any of this information. 120 is a pretty big number, right?
Yeah.
You have to use your knowledge of what the divisibility rules. Check. Is it an even number?
Yes.
Yes, I can always start with 2. But if it ends in 5 or 0, I can divide it by 5. If it ends in 0, I can divide it by 10. If it's if it doesn't work for any of those, the divisibility rule for 3. Add your numbers up. 1 plus 2 is 3. 3 plus 0 is nothing. Can I take 3 divided by 3? Yes. I'm not going to show you this one. So we're going to rewrite an example using 3. So I got 120. I'm going to split it up with factors of 3. Now, how do I figure out what that other number is?
You divide it.
You divide it. And if you can't do that in your head, which is okay, I don't expect you to, you come over to a side and you show 120 divided by 3. 3 doesn't go into 1, but it goes into 12. 4 times 3 is 12. Bring down the 0, so my answer would be 40. I'm going to split that 40. It ends in a 0. I'm going to use my divisibility rule of 10. So it's 4 times
10.
I'm going to use my divisibility rule of 10. But neither one of them are prime. So I'm going to split the 4 by 2 times 2. Oh, I better go back and circle my prime numbers. I need to split 10, 2 times 5. Now when I write it, I start with my lower numbers. So 2 times 2 times 2. Got those done, mark them out. Times 3, mark that out. Times 5. So, using exponents. The only ones I can use exponents for are these right here. So this would be 2 cubed times 3 times 5. Look here. Is that the correct answer?
Yes.
Yes, but I got it in different ways. Okay, if you're at home, and everybody in here, I want you to go back. You're going to have a couple minutes. I want you to go back to the first page. Do A, B, and C. And then complete D, E, and F. You've got about 3 to 4 minutes to complete that. If you're at home, you're going to, after you practice those, you're going to go and work on your homework. Everybody right now, you need to be doing those problems.